Welcome. Today, we are diving into the world of intrusion detection systems. Intrusion detection systems are here to protect our networks and systems through continuous monitoring and threat detection. We will explore how they work and why they are essential in today's digital landscape. There are mainly two types of intrusion detection systems. The first one is network-based intrusion detection systems, and the second one is host-based intrusion detection systems. So, what exactly is an intrusion detection system? Simply put, it's a security solution that keeps a close watch on network traffic and system activities. It is like a security guard that monitors for malicious actions or policy violations and produces reports to a management station. Think of it as a vigilant observer that helps you catch any unusual or harmful activities happening on your network. An intrusion detection system monitors for suspicious activities. It generates alerts when threats are detected. It logs events for analysis and auditing. And it complements other security controls. Now let's explore the two main types of intrusion detection systems, each designed to monitor different aspects of your network and systems. First, we have network-based intrusion detection systems, often referred to as NIDS. These monitor network traffic across entire network segments. They analyze protocol activity and packet contents. They are typically deployed at strategic points, such as network boundaries or demilitarized zones. NIDS can detect network-wide attacks like distributed denial-of-service attacks or port scans. Some examples of NIDS include Snort, Suricata, and Zeek, also known as BRO. Next, we have host-based intrusion detection systems, or HIDS. These monitor activities on individual hosts or endpoints. They analyze system logs, file integrity, and registry changes. They are installed directly on critical servers and workstations. HIDS can detect local attacks, such as privilege escalation or unauthorized access. Examples of HIDS include OSSEC, Tripwire, and Wazoo. Let's take a closer look at network-based intrusion detection systems, or NIDS. Network-based intrusion detection systems monitor network traffic for suspicious activity and policy violations. They achieve this by analyzing protocol activity across the network. NIDS monitors traffic at strategic network points, such as gateways, demilitarized zones, or virtual local area networks. They analyze packet headers and payloads for malicious patterns. They operate in promiscuous mode to capture all network traffic. NIDS can detect network-wide attacks like distributed denial-of-service attacks, port scans, and protocol violations. One limitation is that they have limited visibility into encrypted traffic, such as secure sockets layer or transport layer security. Now let's explore host-based intrusion detection systems, or HIDS. Host-based intrusion detection systems monitor and analyze the internals of a computing system. It doesn't look at its external interfaces. Host-based intrusion detection systems monitors all or parts of the dynamic behavior and the state of a computer system. HIDS monitors file system integrity and detects unauthorized changes. It analyzes system logs and event records for suspicious patterns. It tracks system calls and application behavior. It detects privilege escalation and unauthorized access attempts. It also monitors registry changes, especially on Windows systems. Now let's delve into the core components and functionality of a host-based intrusion detection system, or HIDS. One key component is file integrity monitoring. This component tracks changes to critical system files and directories to detect unauthorized modifications. It creates cryptographic checksums of files. It alerts on unexpected file changes. It monitors permissions and ownership changes. Another key component is log analysis. This component examines system logs and event records to identify suspicious patterns and security events. It monitors authentication logs for failed login attempts. It analyzes application logs for unusual behavior. It correlates events across different log sources. A third key component is behavior monitoring. This component analyzes system calls, processes, and application behavior to detect anomalies. It monitors process creation and termination. It tracks system call patterns for anomalies. It detects unusual network connections from processes. Let's explore the primary methods that intrusion detection systems use to identify malicious activities. First, we have signature-based detection. This method compares observed events with predefined patterns or signatures of known threats. The advantages of this approach are low false positives and easy implementation. However, it cannot detect new threats and requires regular updates. Next, we have anomaly-based detection. This method builds a model of normal behavior and flags deviations from this baseline as potential threats. The steps in this approach are to establish baseline network traffic patterns, monitor for statistical deviations, flag unusual traffic volumes, protocols or connection patterns, and alert when deviation exceeds threshold. The advantages of this approach are that it can detect novel attacks and adapts to changing environments. However, it has a higher chance of false positives and requires a training period. A third approach is behavior-based detection. This method analyzes the behavior of systems, applications, or users to identify malicious activities based on their actions. The advantages of this method is its context-aware detection and effectiveness against zero-day exploits. However, it is resource-intensive and has complex implementation. While intrusion detection systems are powerful tools, they come with their own set of challenges and limitations. One significant challenge is false positives. This refers to legitimate activities that are incorrectly identified as malicious, leading to alert fatigue and wasted investigation time. To mitigate this, you can fine-tune detection rules, implement baselining, and use machine learning to improve accuracy over time. Another challenge is encrypted traffic. The increasing use of encryption limits visibility into packet contents, making deep packet inspection ineffective. To mitigate this, deploy secure sockets layer inspection where appropriate, focus on metadata analysis, and implement endpoint monitoring. Another challenge is performance impact. Comprehensive monitoring can create significant processing overhead, especially in high-throughput environments. To mitigate this, use dedicated hardware, implement selective monitoring, and optimize detection algorithms for efficiency. Lastly, there are evasion techniques. Attackers use fragmentation, obfuscation, timing attacks, and polymorphic code to bypass detection mechanisms. To mitigate this, implement multiple detection methods, keep signatures updated, and use behavior-based analysis to complement signature detection. To maximize the effectiveness of your intrusion detection systems, let's review some essential best practices. First, consider strategic deployment. Place intrusion detection system sensors at critical network points to maximize visibility while minimizing overhead. Monitor network boundaries and demilitarized zones. Protect critical assets and sensitive data. Use both network-based intrusion detection systems and host-based intrusion detection systems for comprehensive coverage. Second, consider tuning and maintenance. Regularly update, tune, and maintain your intrusion detection system to ensure optimal performance and accuracy. Update signatures and detection rules. Adjust thresholds to reduce false positives. Regularly review and refine baselines. Third, consider integration. Integrate intrusion detection systems with other security tools to create a comprehensive security ecosystem. Connect to Security Information and Event Management, or SIEM, for centralized analysis. Integrate with firewalls and intrusion prevention systems. Implement automated response workflows. Remember, an intrusion detection system is just one component of a defense-in-depth security strategy. It works best when combined with other security controls and backed by well-trained security personnel. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.